Hi there, welcome back. I'm so happy you're here. Before I jump straight into the problem that I have put together for you today, I want to show you a free guide that I prepared for you. It is called How to Evaluate Your Engineering Education in United States of America, and it does just that. Let me show you. This is the Education Evaluation Starter Guide. It has a welcoming page here, and then it starts right away with every step you need to do to evaluate your education. Create an account on ncs.org, step number 2, number 3, gives you 4, 5, so on, and then congratulations page, and the page where I'm showing you where you can find more training and videos on my YouTube channel, FE Made Easy, is where you're watching me right now. If you are interested in downloading this file for free, please click the link below underneath this video. Okay, another important thing that I want to remind you is that if you do like this video, please subscribe and give it a like, because this helps people like you find me. It's just the way YouTube works. It helps promulgate my video in front of more people. Now let's move on with our example. Draw the shear and bending moment diagram for the beam shown below. So this is a pretty simple, straightforward, simply supported beam. Let's start by calculating reactions. So I will have here point A, point B, and this is going to be a reaction at B, and here I'll have reaction at A. So I'll do sum of moments, and point A equals 0. From here I will have VB times 8 minus 10 kips times 10 minus 3 kips times 4. That's the resultant force, and the arm is going to be 6 equals 0. So VB is equal to 100 plus 72, and this equals to 21.5 kips. So VB is going to be 21.5, and now VA, I'm going to do sum of moments, and point B equals 0. And from here I'll have VA times 8 plus 10 kips times 2 minus 3 times 4, and the arm is 2, equals 0. VA equals to, I'm going to have 8 24 minus 20, and I will have VA equals to 0.5 kips. So 0.5. And we also, it's a good thing to verify yourself by doing sum of forces in the y direction equals 0. So we'll have VA 0.5 plus VB 21.5 minus 10 kips and minus 3 times 4, which is 12, equals 0. So I'll have 22 minus 22 equals 0, which is true, and this means that we have calculated our reactions correctly. So now let's go ahead and draw the shear and bending moment diagram. Okay, perfect. I will have shear here, plus at the top, negative, and moment, I will have negative at the top, plus at the bottom. So when drawing shear moment diagram for a simply supported beam like this one, you start at 0, and let's read the beam. We're going to go up, right, 0.5, and then looking at the beam, this section is going to be constant, so it's just going to go like this. This is positive, and this value is 0.5 as well. Now, looking at the beam, we're going to have to go downwards with 3 times 4, 12, which means on this side, we're going to end up at 11.5. And just, there you go. This is positive, here negative. And then we have to go up with the 21.5, meaning this value here is going to be 10. And then this section is constant, nothing happens on the beam. So we're going to go with value of 10. And this is positive, of course. And once here, I have to go downward with a value of 10, which ends me at 0, which is perfect. So now let's calculate the areas. So we are able to calculate the moment diagram to draw the bending moment diagram. So we have 0.5 times 4, it's going to be 2. And here, the same thing, let's calculate this distance over here, x. Again, I'm going to explain it really quickly. We're going to do with the similar triangle. So our first triangle is this one, the small one. Or you can take the other one, of course. I'm just going to do this one. It doesn't matter. And then our next triangle is this big triangle, which is if I'm sliding this point from here all the way with a value of 11.5 all the way up here, this side is going to translate all the way up here with a value of 11.5, which means that this big side of the triangle, it's going to be 12. So I'm going to have this small triangle, which has 0.5 and x, and then my big triangle has 12, and this value is 4. Do you follow me? I hope you follow me. If you don't, leave a comment below. So, and now we can easily calculate x as being, so 0.5 relates to x the same way as 12 relates to 4. From here, x equals to 0.5 times 4 divided by 12 equals 0.167. So x 0.167, that means that this side is 3.83. We can also just make it easier and just do this 0.17 and 83. That's better. Okay, so the area over here, we're gonna have 0.5 times 0.17 divided by 2. So the area over here, I'm getting 0.04. And on this side, is 22.4. And here on this side, we have 383 times 11.5 divided by 2. And I'm getting 22.04. Okay. Now here I have 10 times 2, and it's 20. Perfect. So let's start by drawing the bending moment diagram. I will start at 0. We have a support, we start at 0. And I know my diagram is going to be linear and it's going to go towards the positive side with a value of 2. So I'm going to have 2 here. Okay, and this is positive. All right, from here, I'm going also towards, again, remember when the shear diagram intersects like that, you must draw a line because in the bending moment diagram, you're going to have a minimum or a maximum. So here we're going to go, our diagram is going to be parabolic. and I have to go towards the positive side with a value of 0.004, so very, very small, which is gonna end me up here at 2.04. And remember, thinking of a ski slope, you're gonna go fast and then slow, meaning our bending diagram is gonna look like this. Still positive here. And then from 204, look at this triangle here. It goes from a small value to a big value, meaning that I will have to go slow and then fast. And I'm going to end up from 204, I have to, I'm going to end up here at the value of 20. And it's going to look like this. Okay, this is positive. This is negative. All right. So from 20 now, looking at the shear diagram, which is constant, my moment diagram is going to be linear, and I have to go towards the positive side with a value of 20, and it's going to end me up here at 0, which is exactly what we need. And again, if sometimes you're not very good at drawing, you can just write down. Let's not do it here, might be confusing. So this is parabolic, and this is linear. Okay, and this is how our shear and bending moment diagram will look.